Welcome to my 8th video recording and the 7th session on kinematics. And today's topic is motion of a freely falling object. So let's get into this straight away. So we'll discuss 3 scenarios here. Scenario 1 is you're on a platform and there is a ball which is dropped onto the floor straight here. This is scenario 1. Scenario 2 is this is the platform, this is the ground, the ball is tossed up in this direction and then it comes down back to the ground. And scenario 3 is this is the ground, there is a platform here, the ball is tossed up and it comes back to the ground here. So let's discuss how the motion of the ball how the ball will behave in 3 of these cases. So let's start with case number 1. Now before this, please understand what is acceleration. Acceleration we learned in the last class is rate of change of velocity, okay? And every object in space, if this is space, let's say, every object in space is continuously experiencing what? It is experiencing something called as acceleration due to gravity, right? Acceleration due to gravity, and this is denoted by g. This is denoted by g, and this value is 9.81 meters per second square. Please remember this, okay? But though it is 9.81 meters per second square, in all our calculation we'll approximate it to 10 meters per second square. We'll be approximating it to for ease of calculation. Even in your competitive exams, when you take exams, at many places they may ask you to use 10 instead of 9.8, because what they try to generally do is to test your understanding of the concept and how fast you're able to apply your learning. So calculation may not be the most important thing, so they want you to, and you also have to do your problems in about 2 minutes each. You will only have about 2 minutes to solve each question. So which means calculation you cannot do complex calculations. So certain times it is 9.8, you have to work with 9.8, but many places you may be asked to use 10. So with this understanding, let's go with our first case scenario, okay? So let's understand what is happening here. Now let me draw this again here. So this is the platform, this is the ground, and the ball is here, and it is being just allowed to fall free, okay? Now we learned in our last class we learned a few concepts. So what is initial velocity? We denote it by u. So when the ball is allowed to is left to just fall from this point, what is its initial velocity? It is obviously 0 meters per second, right? And when it comes down here, reaches here, it has a final velocity, right? It has a final velocity which we don't know, so we'll leave it as v meters per second. And let us assume this distance from here to here to be 80 meters, okay? So distance s is equal to 80 meters, okay? This is the distance from this point to our landing point. And obviously if you're going to let the ball fall free, it is going to experience an acceleration which will be equal to g, and that will be equal to 9.81 meters per second square. but I told you that we are going to approximate this to 10 meters per second square for calculation purpose, right? Now let's go and solve this. Do you remember the three equations that we discussed in our previous class? I'll just, for your benefit, I'll write it. V is equal to u plus at. Second one is s is equal to ut plus half at square, and third one is 2as is equal to v square minus u square, right? Now let's apply these equations to our case here. So you can see, so now what we want to find out, let's assume that we need to find out how much time the ball has taken to travel from here to here. So obviously you see, you know u, you know v, you know s, and you know g. So obviously the most simple formula to apply here will be formula number 2, right? So let's go and apply it. So what is the formula? S is equal to, my handwriting, wait, ut plus half at square. So let's start applying the values. So s is 80 meters, fair enough. Initial velocity u is 0. Since it is 0, this term becomes 0, so there's nothing. Therefore this will be equal to half. What is acceleration? Acceleration is 10 meters per second square into t square, which we don't know. Therefore this implies t is equal to 160 by 10 under root, which is 16 under root. This is equal to 4 seconds. Is this clear? No doubts about this, right? So we find that when this ball is allowed to drop freely from a height of 80 meters above the ground, it is going to take 4 seconds to get to the ground. And if I ask you what will be its velocity just before touching the ground, we are going to use a different formula, which will be this. So it's nothing but v is equal to u plus at. Again u is 0, therefore answer is 10 into time taken is 4. That is equal to 40 meters per second, right? So you see, this is the final velocity. This is the final velocity. So this is how you calculate when an object is dropped freely from some position and is allowed to fall freely on the ground. Now, so this we will call as our first case scenario. Now let's go to our second case scenario, which is this, right? So let me draw this here. So here we have the platform and the ball is here. So we're tossing it up, it goes up and then it comes down. All of you have played with a ball. So when you throw anything up, it comes down because of gravitation, right? It comes down. So now let's go ahead and work this out. So now in this case, tell me, the ball is being thrown from here. This is your initial place. It goes up and it also comes down and it lands right in the same place. So what is the displacement? What is the displacement in this case? It is 0, because the starting point and the ending point are the same. Therefore s is equal to 0. What is the initial velocity? Let us assume that the ball is tossed into the sky, or tossed vertically upwards with a velocity of 10 meters per second. Let us assume this, okay? And we know g, which is acceleration due to gravity, it is 10 meters per second square. Again, please note it is 9.81, but we are approximating it to 10 meters per second square. Do we know anything else? That's all. We don't know anything else, right? So now let us go and apply our formula. Again, we will see that probably this will be the best formula to apply in this particular case. So let's go and apply this. So let's assume, so let's say s is equal to ut plus half at square. Now comes a very, very important part which I want you to understand. Do you remember I mentioned to you in our last class that all these are vectors? All these are vectors, right? So if these are vectors, what becomes important? Direction. Direction is very, very important. Now you have to understand how to use sign conventions. Sign conventions. Sign conventions. Let me just explain this to you. Now, please understand this. Obviously, displacement is 0, so we don't need to bother about this. Since it is 0, there is no question of a sign here. Okay, anything 0 is neither positive nor negative. Now, what is the velocity? Velocity, the ball was thrown in this direction, right? So this is the direction of v, initial velocity. This is the direction of v, correct? Now tell me something. In which direction is gravity acting? In which direction? Any object that is in the air is always acted upon by a gravity g, which is always downwards. Please remember this. Anywhere, even if the body is temporarily traveling in the upward direction, it is being acted by a gravity which is pointing downwards. That is the reason the ball slows down and then comes back. So g for any object which is freely suspended in the air is always going to be downwards. It is always going to act downwards. So v is upwards. So we can see our v is upwards, but our g is going to be downwards. So naturally, now we need to understand. So this is a convention. Basically, what a convention is conventions can be as you please, but should be consistent. Should be consistent. Okay, please understand this. So in our case, or let's say the way I like it is, I like to go everything on top, and everything pointing upwards as positive, everything pointing downwards as negative. Look, this is my convention. This is the way I want it, or I like it. If you want it in a different way, it's fine. So, but just remember that it needs to be consistent across the problem you're attacking. So if I go by this convention, if I go by this top is positive and down is negative, in that case what will happen? My v will be 10 because it is acting in the upward direction, but my g now will not be 10. Since it is acting downwards, it becomes minus 10. Please understand this concept. Okay, my g becomes now minus 10. Very, very important. That's it. We don't have any other constants here. So let's go ahead and solve this. So s is 0 is equal to u. I'm sorry, this is going to be, I'm very sorry, this is going to be your initial velocity. Okay, I'm always making a mistake here. So this is your u. Sorry for the mistake. What is your initial velocity? Your initial velocity is 10 meters per second. So 10t plus half into, what is your acceleration? It is minus 10, right? Into t square. Okay, so this will be, obviously this will go minus 5 times. Therefore, what will you get? You will get 10t is equal to you will get minus 10t is equal to minus 5t square. So minus minus goes, and this will go 2 times. Therefore, your t will be equal to 2 seconds. Therefore, if you are going to toss the ball with an initial velocity of 10 meters per second from here and allow it to go up and fall freely, the total time it will take to reach back will be just 2 seconds. I hope you get the idea. Let us now go to our third case scenario. Let me draw this here. So this is the ground, this is a platform, and your ball is being goes up and it comes down here. And let us assume, so now again let's work on the sign conventions. Okay, let's make some let's make some assumptions, not assumptions exactly. Let us say that we want to find out S. We don't know S, and we know that the initial velocity of the ball was, let us say, 60 meters per second. Let us assume it was 60 meters per second, thrown in the upward direction. It was thrown in the upward direction, right? So just for representation, I am showing you the direction so that we don't make any mistakes in the signs, right? Now S, okay, S of course is something we have to find out, so we don't know S. Okay, so we don't know S. What is our G? G is 10 meters per second square, always acting in the downward direction. I told you acceleration due to gravity is always in the downward direction. And let us say the entire time taken for the ball to travel from being thrown up to reaching this point, let us say, is 6 seconds. Okay, so we have to calculate now what is the, how high is the platform, or this is how high is this platform. So now again, very simple, let's apply our formula. S is equal to ut plus half at square. Now see the treatment here. S we don't know, so we leave it as it is. Okay, now again our convention is everything going up, every arrow upwards positive, everything downwards negative. So this is 60 going up, so it is going to be positive, no problem. G downwards, so we are going to use negative. T obviously has, T is, time is scalar, so no sign, right? It's a scalar quantity, time is a scalar quantity. However, this are all vector quantities. So right, so now we have 60. Okay, let's do one thing. Instead of taking 60 looks a little it looks a little unnatural. Let's use 10 meters per second. Right, and that's possibly more realistic. So therefore this will be equal to 10, right, into what is the time taken? Time taken is 6 seconds, plus half into what is acceleration? Acceleration is, see the signal, see the sign, minus, downwards, so it is minus 10 into t square. T is how much? 6. T square is therefore 6 into 6 is 36. Clear? So therefore S is equal to 60. So how much this will go? This will go 18 times. Therefore this will become minus 180, right? Or this implies 60 minus 180 is minus 120. So this is our displacement. This is our displacement S. And please note it is negative. So if it is negative, that means obviously it is saying that, if it is negative, it is obviously saying that our S is in this direction. Remember the sign convention? Since we got the answer in negative, that means it is downwards. Therefore, as you can see, this is definitely, our platform is much higher than the ground. Therefore, this distance from here to here, as per our calculation, will be minus 120 meters. So I hope you completely grasp this concept of sign conventions. Please take a few problems and do it for yourself, because certain times what happens is, generally I see a lot of students getting this wrong because they confuse with these sign conventions. So just to summarize, what you will do is, first point is list U, V, T, S, G, etc. 2 is put the correct positive or negative based on the planned sign convention. And 3, apply formulas, 3 formulas as required, as applicable. Okay, please understand this, very important. So it is important for you to list all this, and then this is very important. You need to put the right sign convention, right? And then of course application of formula depending on what unknowns you need to find out. So please go through your textbook and try to solve a number of problems by applying this simple logic, and I'm sure you'll erase all kinds of confusion that you might have in this chapter. So I'll see you in the next chapter. Thank you.